Hello everybody and welcome to section 3.1. Today we're going to look at derivatives of polynomials and exponential functions. Today is the day that you won't like your calculus teacher. You might have thoughts, not sure if I hate calculus or I hate the teacher. Just kidding. You don't hate me. You don't hate Mr. Johnson, and you won't hate calculus. The biggest thing is I'm going to show you some shortcuts today. So you're going to be a little angry that I've made you do it the long way to find the derivative using the limit definition. But now I'm going to show you some shorthand tricks to make finding the derivative a little bit quicker. So you might just be a little frustrated, but you had to do it the long way for your last test. So it's just the way it is. All right, so let's go ahead and take a look. Here are some examples of problems that we have taken the derivative of using the limit definition. So we had x squared, and when we took the derivative, we got 2x. Okay. Here was g of x squared minus 8x plus 9, and we took the derivative, and we got 2x minus 8. Here was another one. We had h of x, 5 minus 2x cubed, and you got negative 6x squared. And then you had s of t. So I'm going to give you guys a second. Just take a look. How would I go from the original function to the derivative? The original function to the derivative. Some of you might start to pick up that it has to do with your exponent. If you go ahead and take your exponent and you bring it down in front. So I brought that 2 down in front, so I'd have 2x. And then I had a 2 in the numerator. What you do is you subtract 1. That gives me 2x to the first. That is your derivative of x squared. That's how you do it. Let's check it out here. Bring that 2 down. We got the 2 in front, and then x to the, you take 2 minus 1, we get 1. Okay, let's check out this one. This one had a 1 as an exponent. We bring the 1 down, so I got negative 8 times 1, which is negative 8. Then it would become x to the 0. Well, x to the 0, or anything to the 0 is really 1. So that's why there is no x there. And then lastly, this is really x to the 0. If you want to think about 9x to 0. If I bring the 0 down, 9 times 0 is 0 times x to whatever you'd have there would be 0. So that is your shorthand trick for taking your derivative. But today we're going to be practicing how you would do this with polynomials and then exponentials. But that is our introduction, and we will go ahead and practice taking some derivatives on our next video.